Hello and welcome back to the lab. Once again, I'd like to thank everyone for joining in these series of videos. I would also like to thank the patrons who continue to help keep the lights on in the lab. Your help is greatly appreciated and more than you guys know. In this video, we need to take a look at a critical piece of the lab that I've used in a couple of videos, specifically working on the distortion analyzers. And it is my SG505. Now, this one is kind of sick, and I was using it a couple of weeks ago, and it started displaying some issues. So, I'm going to need to repair it. I've been very, very hesitant to go into this analyzer because of its distortion specification and what that could possibly mean for repair, because I had no way of validating it. I could validate it to the noise limits of my A501s, which is about 8%, 0.0008% THD. Typically on these, they go down to 0.0003. This unit specifically is an option 2, as it has the dual inputs. This is a balanced output, and even the service manual says if you do not have reason to suspect the distortion is off, don't check it, because it is a very lengthy procedure, because this is really getting the signal down into the noise and very hard to work with. The unit that I was missing is this guy right here. So this is the notch filter that is used. The only thing I'm aware of is this is good to notch out the fundamentals of frequencies up to 1 kilohertz. It's a set notch at these frequencies. It's not a permanently adjustable notch filter, so it doesn't have that much utility outside of validating the performance of an SG505. But without it, even my spectrum analyzers cannot validate the performance of an SG505. Part of the reasons there is the SG505 goes fairly low in speed, 10 hertz and below. Even my slowest spectrum analyzer in the lab doesn't go down to 10 hertz. It stops at 20. My E4411, which has made appearances in some videos, that spectrum analyzer actually really isn't useful for an SG505, even though it has internal distortion measurements, because this is primarily in the audio range, although it does go up to, I believe, 100 kilohertz. However, the E4411 starts at 9 and goes to 1.5. So I can't even, a lot of amplifier testing and things like that is done at 1 kilohertz. So I can't even validate the 1 kilohertz distortion spec with my 4411. I have to use my 3585B, which tops out at 40 megahertz. So between the instruments, I have a nice wide range of, I have a nice frequency coverage here in the lab. The other thing with these SG505s, even with modern equipment, you're going to be hard-pressed to find something that beats these things' distortion measurement, or distortion capabilities. I have looked. There is not much out there that has a cleaner sine wave than the 505 units, both of them. I happen to have a second 505 in the lab, which is an option 1 unit, and I may add probably one more option 1 unit if it becomes available. I might be interested in pursuing that. The option 2 units are incredibly rare. I know of 2. I own 1, and I've seen 1 more go up for sale. So the option 2 units do not go up very often. The option 2 unit is way more complicated than the option 1 and the no option unit. So there is a lot going on in this thing. I've already replaced these 2 capacitors with new ones. There's a lot more caps that I'm going to go after. I'm going to recap this entire unit because I think that's part of what's happening. There are some parts that I need to be extremely careful with, especially with the op amps in here, because the op amps are kind of how this thing does its magic. I do have a frame of this. If anybody has a dead one, I need this board, the output board, to get that second one working. I'm not optimistic of that ever living again. So to put that into comparison between a non-option 2, there is a lot less going on in a non-option 2. So, but let me show you what it's doing, and hopefully what we can get fixed. Well, I have a, do I have it set to 0 dBm? I think I do. No, negative 8 dBm into 600 ohms. So we have plenty of signal for driving the frequency counter. I have the trigger set to 70%. We can even lower this to 50%. But problem number one is the frequency is not stable at all. It's bouncing around pretty good. So that's going to cause some problems when aligning AA501s and a few other things. If the frequency is not stable, the notch filter doesn't know what to do, and it can't get the noise down where it wants to. So I need to get this fixed because the frequency needs to be stable. It is currently set to 1 kilohertz, but it's still not hanging out, not very stable. So we're going to check power rails and capacitors first before we do anything else. Now that we're in this unit, there is quite a bit to do. I got caps everywhere that need to be replaced. This one, these guys, these guys, these guys. There is a couple of non-polarized capacitors here on the back of the unit that I'm going to work on getting fixed. There's a lot going on in here. I'm not going to change those non-polarized caps out immediately because I can get to them without removing the output board. There is some extremely fragile ceramic resistors, ceramic hybrids on here. They have TekTronix part numbers, so I'm going to have to be real careful while working on this thing so we don't kill it. But yeah, we'll get some of this stuff replaced, and we will go from there. Okay, let's check to see if after the repair, the unit smokes out. So I've got a power supply hooked up to the device under test. This is the SG505 option 2. We have a scope here. Pay no attention to the random triggering. That's just the noise in the lab. We are plugged into a 7A18, and we have a frequency counter up here. So we'll see if the frequency is bouncing around. The gate time on this frequency counter is quite long. It's 10 seconds. So it'll give us a very accurate frequency, but if you watch the dot here, it'll take a while to cycle. I have the unit set up for 1 kilohertz. And let's go. Actually, let me go around here. I do not know how fast this will start. Quite quickly, actually, apparently. Don't pay attention to the first cycle, so we need gate time to go. Let's see, it just gated, so we're at 1009. We'll see if it bounces around. Looks okay from the scope. Turn this up a bit. Nice clean sine wave too, so that's a plus. 1001, much better than it was bouncing around before. So let's let this burn for a little bit. If the testing works out okay here, I'm going to throw it into one of my TM5006 frames. That's going to test a couple things at one time, and we'll go from there. Okay, it's been a while, and everything's gotten nice and warm. And we are still nice and stable. Frequencies come down a little bit as the gear's warmed up. And everything looks really, really good. So, can't complain there. Everything looks pretty fantastic. I'm going to throw this up in my TM5006 power frame. And I'm going to do 2 experiments at once. One, we're going to check the distortion on the AA501A. And the other one, we're going to check whether the recap of the unit gives it stability in that particular power frame. I was having some trouble with this unit in the switch mode power supplies. It was giving me a little bit higher distortion than it should have been. So hopefully the recap will have fixed that. We're going to test both at the same time. And then if everything looks good, we're going to dive into, I'm going to get the gear set up, and I'm going to do at least check the 1 kilohertz range with the calibration fixture, just kind of give me an idea on how this unit is performing. I'm going to get some stuff moved around and repoint the camera. Okay, here we are at the TM5006. We are at full power, 22 plus 22 dBm, with the input THD is set. We're not looking at level. I do have the A-weighted filter on because that gave me the best distortion measurements in the past, and I am also checking on the 1 kilohertz signal. So, what do we look like? Not bad so far. So, before I did the repair, this unit would test at 0.008 on the AA501, so it very much looks like we may not have disturbed the distortion measurement, or the distortion output, which is fantastic. But what I'm going to do, because I ran through the calibration document and I took a look, I need the calibration fixture, which is the notch filter, which is here, but I also need the AM502, which we restored in a previous video, which is here. So what we're going to end up doing is taking the oscillator to the input, to the output, to the AM502, running the AM502 down to the spectrum analyzer, which is right below, and we'll check the 1 kilohertz bandwidth. So I'm going to get the spectrum analyzer fired up as it wakes up, and then we'll see. I'm hopeful, but we'll see kind of what this thing's even given us. Okay, there is quite a bit going on here, so I will let you guys know what is happening. I needed to press into service the other ones up here, that's what these cables are, 2 decade resistor boxes to get the loading that I needed, because the positive side and the negative side both need to be loaded for this. I needed to press into service this spectrum analyzer, and I have that set up in a way that made looking at the data a lot easier, but also gave me the worst metric, which was over time, which was kind of what I was looking for. Pardon the cables everywhere. This is the input coming in from the notch filter. I notched out the fundamental as much as I can. We do still see some fundamental. And I have, let's see, the document wants us to look at the 5th, up to the 5th harmonic. We're on 1 kilohertz, so we're going up to 8 kilohertz over here. Our 1 kilohertz signal is here. And then here's what we have for harmonics. Reference level is a negative 60 dBm, and as is always important, we're not overloading the input. Now, the important part for this measurement, this particular unit has a 1 megohm input. That's not normal on a lot of spectrum analyzers. A lot of spectrum analyzers have a 50 or 75 ohm, depending on what system they were built for. This is a slower spectrum analyzer, and it does have a 1 megohm. And it turns out this is the slowest spectrum analyzer that I have in the lab. It's not slow enough, which is funny. I will need a dynamic signal analyzer to fully validate this unit. Now, the interesting thing there is I don't have to, since I've kind of done a sanity check here, and I also have a AA501, I can very quickly validate this SG505 to the limits of the AA501, which is pretty close. Not unhappy with the way that turned out, but I did want to go through the long form in the calibration procedure and validate it, since we kind of offended it by taking it apart and replacing a whole bunch of capacitors. So as we can see, the spectrum analyzer is happy, and we don't have a lot of harmonic distortion from this output. This is still running. I do have the spectrum analyzer in max hold mode, which is showing me the worst case scenario. So as it does sweeps, it is showing me the highest level of signal that it is seeing, which is fine. I think I am at the limits of this spectrum analyzer, to be perfectly honest. I got better than specification, but a little bit worse than typical for the distortion at 1 kilohertz. And when the TekTronix service manual said this was an arduous process, they were not kidding. To fully validate an SG505, you do this entire process in 10 hertz steps all the way up through the ranges, which is kind of crazy. So I picked the 1 kilohertz range to validate, which is right smack in the middle of the audio band, typically where this thing likes to work. It's also at the lowest distortion specification on the datasheet. As I was editing the video, I realized I misspoke when I talked about calibrating the unit. It is not every 10 hertz. That was a misunderstanding for me reading the calibration document. It's 10, 20, 100 hertz, 1 kilohertz, 10 kilohertz, 20 kilohertz, 50 kilohertz, and 100 kilohertz is where the calibration points are. I can now buzz through this with the distortion analyzer and spot check any frequency I want and know that I am probably good. Let me show you the math, because there is a lot of it. I'm going to post this on Patreon just in case anybody else is interested in doing the absurdity of validating one of these from front to back. I did create an Excel sheet and I have triple checked the math. Let's take a look at that. Okay, here is our Excel sheet that I have worked up to get to the total harmonic distortion of this unit. And when the tech manual said this was a process, they weren't kidding. Let me get a pointer here. So what I've done is we have the second, third, fourth, and fifth harmonic. This is the measured dBm value coming from the spectrum analyzer, knowing that this is not a 50 ohm dBm. This is a 1 megohm dBm. The harmonic correction factor. This is because the calibration fixture is a 100% passive filter, so there is a little bit of a correction factor that needs to be applied. That comes out of the manual from 10 hertz to 20 kilohertz, essentially the audio range. These are the correction factors you would use. Above 50 kilohertz, there is a different set of correction factors, and above 100 kilohertz, there is yet another set of correction factors. That's just due to the physical properties of the notch filter. So we take all of these, add the correction factors to the measured value, which gets us to this column. After we get to this column, which is the addition of the correction factors, we divide by 10 and then raise to the power of 10 this number, which ends up giving us this column. Now, this Excel document will compute all these values for you. All you have to do is plug in the measured value and you're off to the races. What I have done is actually, I have, if I remember correctly, this divides by 10, this raises to the power of 10. So that's how it goes across. So measured value, harmonic correction factor, add, divide by 10, raise to the power of 10. We then sum those values, just straight addition. Take the square root of this number, which ends up being that number. We then take the log of that number, which ends up being that number. And that gives us our total THD in dB. On the 1 kilohertz frequency, we're going about 105.017948 dB. Fairly accurate. Well, at least that's what the numbers say. To express that in a percentage, we are at 0.00056% THD. That puts us under the 0.0008% THD, or negative 102 dB. It does say the units are typically 0.0003% THD, so we're a little bit above that. I am not sure, given how high that bar graph is, or the spectrum is on the spectrum analyzer, I am not sure if we're not hitting the noise floor of the spectrum analyzer, and this particular spec an cannot do much better than that. So I may, if I get some better low-speed equipment in the lab, I may be able to dial this in a little bit better. But for now, it does validate it's in specification, so so I can now believe the AA501 and know it's not a fluke. So let me unhook all of this stuff. We'll throw it into the AA501 and just kind of spot check some of the distortion levels. I should also mention that due to the balanced output on this particular unit, you actually have to do this entire procedure twice, because you have to do it for the positive side and then you have to do it for the negative side. So, because depending on how the balance is, let's see how well this works. 0.008. Pretty good. So the bottom plug here is the center tap on the oscillator, and then we can go into fully balanced mode by not employing the center tap. So let's just spot check some stuff. Let the notch settle. So it is doing quite well. We'll pull the A-weighting filter out and we'll go up to 5 kilohertz. Now, no, that's 50 kilohertz, sorry. Up to 50 kilohertz, the THD changes. Because up to 50 kilohertz, it's 0018. So, but we can also, that's 5 kilohertz. A-weighting filter on. Very good. This is also measuring a lot more of the harmonic content than the spectrum analyzer would, where the spectrum analyzer and the worksheet test up to the 5th harmonic. The AA501 is looking at stuff out to 300 kilohertz. So that's why the numbers can be slightly askew. But this particular SG505 is working quite well and should be good to go for some projects here in the lab. As always, if anybody has any questions, feel free to hit me up in the comments below. I am there after every video. There is a growing selection of Amazon affiliate links for the channel. Those give me a slight kickback if people use those. However, everything that is on the Amazon affiliates page is supplies and equipment that I use in the lab on a daily basis. So feel free to check those out. That is a link in the description of this video as well. As always, more is always on the way, and I will see everyone in the next video.